the given problem is find if path exists in graph. So here, what is first meant by graph? The graph is nothing but the collection of vertices and edges. Now, what is vertices? Edges means vertices means here 0, 1, 2. The values are the vertices and the edges are connections 0 to 2, 2 to 1 and 1 to 0. And how can we represent the graph data structure? Using first thing is array representation, that is 2D array. You can see, you can think like the a of usually we have like a of source, then the next thing is destination. So if there is an edge, you can put as 1. So like if there is a 0 to edge is there, right? So we could put an 1. And there are some types of the graphs as well, like they are directional, unidirectional, bidirectional, directed graph, undirected graph. This is like here undirected graph, this is bidirectional. And there are other classification of graphs as well, cyclic or weighted or connected kind of. Then one more another way we can represent is adjacency list, that is the list of index is represent the source, and then whatever it's connect the components inside it, it shows the destinations part, I mean connections. So list 0, it is connected to 0, right? Then also 0 is connected to 1, then it is connected to 2, then list 1 is connected to 2, then 0, like that. This way you can see here. For this we can understand this way. Suppose this is a graph 0, 1, 2 I created, then here this is the adjacency matrix representation, this is adjacency list representation. Now so for that, so to store instead of 2D matrix, I will create a array list here. So like because they have given this and bidirectional graph with n vertices, each vertices is 0 to n minus 1, it is 0 based, and the edge in the form of 2D array, edges of I, u of I, v of I. Then each vertex space connected by at most one edge and no. So we want to determine whether like there is a path from source to destination. Suppose the edges are given here 0, 1, 1, 2, 2, 0, and source and destination. So for that to store, I will take the 2D for the representation part. I will take this, and this, suppose let's take this as a graph that is equals to new array list. Now for the number of vertices is I equals 0, I is less than n, right? The given n, then I plus plus, then I will simply do graph dot add of new array list. Like you can take any representation here, new array list of integer. Now let me convert that given 2D array in the form like this is how 0 to 1 connection will be there, 1 to 2 connection will be there, 2 to 0 connection will be there, like the representation given. So now I'm converting the 2 into 2D array list into 0, I is less than I edges dot length, then I plus plus, then let's take into u is equal to starting will be like edges of I and 0, like then int v is equal to edges of here we can have I, then 1, like then I'm just adding the two graph graph dot add of, actually the first thing is get of u, then add of v, because it's bidirectional I will add both graph dot get of v and dot of add of u. So here this basically means we are now adding in the graph. Suppose in the 2D array list, the list we just adding like first get of u, that is g 0 dot add of v, that is a 0 based. For that let's understand here, like 0 1 2. In the 0 based we are adding 0 is connected to 1, right? 1 comma 2. And then in the 1 we are adding 2 comma 0. Then in the 2 based, like it we're adding 2 is connected to 0 comma 1, right? Like that the representation is done. Now let us understand BFS or DFS. These are used for graph traverses. BFS we use queue data structure, DFS we use stack data structure. End of the day both are like the same principles. First we will visit the node, then we will explore the node. So this is basically what we is required. We should check whether there is path from source to destination. Suppose there is 0 to 2, there is path is there, but when here 0 to 5 there is no path, right? So that one we will put everything these two here to the array list like this. Then we'll visit every node and we'll explore all and we'll make that into is visited. Like we'll use like two things. The first thing is here for the BFS part we'll use for the things are we'll create one queue data structure, then we'll create one boolean. That is, first we'll create one queue data structure, then we will create one boolean array is visited. That is a new boolean of size will take n. Like you can take here the boolean of size 3 and the queue data structure, like starting itself no need to define size. Then these are a list 1202 and with indexing that is nothing but the sorts. Now let's start with any sorts like q dot add of sou or ce. Then I'll make these visited of my particular that sorts is equal to true. So first we are making the queue in the suppose let's start with the source kind of 0. Then boolean will be like the 0, it will be we will write here true. Then q we are adding with the 0. Then so visited one node, that is 0. Now let's try to explore it. That is will like it will be like the queue should be empty until we do the process. So for this let's visualize this part here. So if you try to visualize, first thing you can start with anywhere. Then then it will check until the queue is empty or not. It will check the neighborhood. 0 is connected to 1, right? 0 is connected to 2. Like it will check whether 2 and 1 are visited or not. Then after 2 and 1 will be added to the queue. Then 2 visit queue 2 neighborhoods, it will check whether it's visited or not. And then 1 it's visited with whether it's neighborhood it checked or not. Like you can again check here the BFS part. You can start with any node here. 0 it will visited, then explore, then it is visited, and then explore all other nodes. Wherever it's visited we will check this condition. So is visited while we'll check this condition while y q dot size is not equals to 0. So I will take that int node is equal to q dot poll. That that nothing but here ours is like kind of 0. First we visited 0, then we'll write that loop for int I equals to 0 and I less than graph dot get of our particular suppose 0 or which vertices and dot size we'll check with that particular size. One that was 0, we'll check with 1 and 2 and 1 0 2 2 0 and 1, then it is I place place. Then here I will check int neighbors. I will check all the neighbors, that is graph dot get of node dot get of my I. Then I will just check if that visited of my neighbor that is equal to false. That means if it is not visited, then I will make here, I will add that q dot add of that particular neighbor, and also I will make is. So is visited is used for tracking of this only neighbor that is equal to true. So this is the logic. So first thing is I will add this q dot and visited these two here. And after adding this, I will take while my q dot size is not equals to 0, then I will take this int node that is a q dot poll that is 0. Suppose here 0, then print equals 0 I less than graph dot node I dot size, that is here nothing but I'm checking with 0, the 0 base index with 1 and 2, like here you can see, and then I will keep like checking this. Then I'm taking that neighbor. So int my neighbor is graph dot get of node and get of I, that is a 0 of this is the size is 0 comma 0, right, then 0 comma 1, like that. Then I'll check whether it's visited or not. So whenever if it is not visited, suppose 0 comma 1 1 it is not visited right here, so you can check here 0 will be removed here itself starting because we have pulled it. Then I will add here like 1 comma 1 and 2 here because 1 and 2 not visited, right, initially everything will be false. Now when it's going to visited, I will go again other loop and true true. So now 1 2 and all everything is visited, then 1 2 still will be there and 1 will check with 0 0 already true true, so it won't check again. So it is for is visited is checking for not to check repetitions. Then is visited false. Whenever is visited false means I'm just adding here q dot add of my neighbor. Then I'm making is visited of my neighbor also true. So as I said, if there is really the path is there, if there is a really the path is there, If I will close this, if condition, then for loop, then while loop. If there's really path is there, if the source destination will be visited, if the path is there, or it will return false. Let's run this. So the code is running successfully with the checking proper indentation and everything, and it got submitted.